Hello everyone, welcome to Chemistry EduHub channel. Today's class is about the Bohr's atomic theory. The second class, we are going to talk about the Bohr's postulates, merits as well as demerits. So by the name itself, we can understand that this theory was proposed by the scientist Niels Bohr. This theory is based on both Rutherford's model as well as the Planck's quantum model. Let us discuss the postulates of this theory in detail. So what is the first postulate or the first prediction of Bohr? He says that atom is spherical and at the center there is nucleus. If this is the whole atom, at the center there is nucleus. This nucleus has both protons and neutrons. And what about electrons? Electrons are, the first postulate says electrons revolve around the nucleus in certain fixed paths called orbits. Now these paths are circular, so you call fixed circular paths called orbits. So around the nucleus you see the electrons revolving in a circular path called orbits. Now these orbits are called stationary orbits or energy levels or shells. Why is it so? Because now each orbit will have fixed energy. Each orbit is associated with a fixed amount of energy. And do not radiate any kind of energy and does not radiate energy, which means as long as the electron is in a particular path, its energy is fixed. It does not lose energy or gain energy. Such shell or orbit is called stationary orbit or energy level or shells. The third postulate is there can be any number of possible circular orbits. There are many possible circular orbits around the nucleus in an atom. Around the nucleus in an atom, or you can say in each atom. And each orbit is represented by the symbol. Each orbit is denoted by n. What is n? N can be called principal quantum number or you can say it's a Bohr's integer. N value starts from 1, 2, 3, so on up to infinity. So if n is 1, you call it first orbit or K shell. If n is 2, second orbit, L shell. If n is 3, it is third orbit, M shell. Likewise, you will have K, L, M, and O and so on. If this is the nucleus, this is the first shell, second shell, third shell, fourth shell and so on up to infinity. So as the n value increases, what happens to the distance between the nucleus and the outermost shell? That is the radius, or you can say this is the center to the outermost shell. The size keeps on increasing, radius or size is one and the same. So size of the atom or the electron orbit increases, size of the orbit, and also energy of the orbit also increases. So with the increase in the n value, size as well as energy of the orbit increases. There can be any number of orbits possible around the nucleus in between 1, 2, 3 and 4, but the electron revolves only in those orbitals or orbits. Electron revolves around the nucleus only in an orbit in which the angular momentum, its angular momentum value is, angular momentum is mvr, linear momentum is mv, is an integral multiple of h by 2 pi. So there can be any number of orbits possible between 1 and 2, 2 and 3, 3 and 4, but you can see the electron present only in the orbits with the mvr value equal to n into h by 2 pi, where n can be only 1, 2, 3, 4 and so on, but not 0.1, 0.5, 1.5. These decimals are not possible. So the angular momentum is said to be quantized. Angular momentum is quantized. Now what is m here? M is the mass of an electron, v is the velocity or speed of an electron, r is the radius of the orbit in which the electron is revolving, h is the Planck's constant, n is the shell number or orbit number, and pi is anyways a constant, known constant. The electron jumps from lower energy level or lower orbit to the higher energy level or the higher orbit. Now, while moving the electron from lower to higher, it absorbs energy. That means its energy increases. So that's why it's going from lower to higher. And at higher energy orbit, it is unstable because energy and stability are inversely proportional. So hence, the electron has to come down to the lower energy orbit. So while it is coming down, it emits energy or it loses energy. Emits or loses, absorbs or gains energy. So the difference in energy, delta E, is the difference in energy, which is nothing but higher energy level minus the lower energy level, which is h nu, that is the Planck's equation. So lower to higher, the electron jumps from lower orbit to higher orbit as it absorbs energy and jumps from higher to lower as it emits energy. Now the difference in the energy of radiation that is taking place, whether it is an absorption or emission, the energy of radiation emitted or absorbed by the electron is equal to the difference in the energy of two orbits. So delta E is nothing but E2 minus E1, which is equal to h nu. E1 is the energy of lower orbit and E2 is the energy of higher orbit. Always we subtract higher minus lower. The electrons keep revolving around the nucleus in an orbit because the two forces that are acting on the electron are balanced. What are the two forces? The electron and the nucleus, since they are oppositely charged species, there is an attractive force called electrostatic force. Electrostatic force of attraction between the nucleus and the electron, that is pulling the electron towards it, and also there is an outward force that is pulling the electron, that is the centrifugal force. So there is an inward force called electrostatic force, there is an outward force called centrifugal force. As these two forces are balanced, the electron stays in a proper orbit or it moves in a circular path. This explains the stability of an atom. These are the postulates of Bohr's atomic theory. Let us talk about the merits and achievements of the Bohr's theory. Merits or achievements is one and the same. So Bohr's model explains the spectrum of hydrogen and hydrogen-like ions. What are hydrogen-like ions? Helium plus, lithium plus 2 and beryllium plus 3. These are called hydrogen-like ions because they also have one electron in them. This plus indicates the loss of electrons. So spectrum can be applicable only for hydrogen and helium plus, lithium plus 2 and beryllium plus 3. Second merit is this model explains the stability of an atom because the energy of an electron in orbit, that is, as long as the electron is in a particular orbit, its energy is fixed. So there is no falling of electron into the nucleus. Hence, the atom is very much stable. The radii of various orbits and the energy of electrons can be calculated using Bohr's theory. That means Bohr's theory provides the values or the formulas to calculate energy and radii, and whatever values are obtained are in agreement with the experimental values. So they are all matching with each other. So this is a merit. And the frequency of spectral lines. So when the electrons are absorbed and emitted, we observe the spectrum in the form of a graph this way, and the frequencies or the new values of these lines are in exact matching with the theoretical equations. So these are the four main postulates of Bohr's theory. Let us talk about the demerits or limitations or drawbacks. So these three terms are one and the same. Bohr's theory fails to explain the spectrum in multi-electron atoms. So we said it is applicable only for single electron species. So whichever atom has greater than one electron, this Bohr's theory cannot discuss the spectrum in it. So it's a failure. This theory fails to explain the fine spectrum of hydrogen. So whenever we observe the hydrogen spectrum under the high resolution electron microscope, then we see the one line splitting into further smaller lines. Such spectrum is called fine spectrum. Now that fine spectrum was not explained by the Bohr's theory. So it's a failure. Next, it is failed to explain the Zeeman effect and Stark effect. Now what is Zeeman effect? It is the splitting of spectral lines. Splitting of spectral lines in the presence of magnetic field. Similarly, splitting of spectral lines in the presence of electric field is called Stark effect. So whenever electric and magnetic fields were applied, then we observe the splitting of the spectral line in the same way as fine spectrum. So why those lines were splitting? The Bohr's model could not explain both the effects, that is Zeeman and Stark. Then Bohr proposed a flat model. He said that around the atom there is a circular path or a two-dimensional path called orbit. But in nature, the electron is moving in a three-dimensional path called orbital. So it's a failure. Then Bohr proposed electrons revolving in definite orbits, but in nature, light and electrons both are having wave behavior also. So that Bohr did not explain. The last and the most important demerit of Bohr's theory is, according to Bohr, position and velocity of an electron can be calculated accurately and simultaneously, which means he says that electron is revolving around the orbit. So in that case, we can know the speed with which the electron is moving and the position where the electron is exactly there, because he considered it is an orbit. But according to Heisenberg uncertainty principle, we cannot find the position and speed of an electron together. That means either you can find the speed or the position or the speed, but not both simultaneously. So this is the contradiction for the Heisenberg uncertainty principle. So that's a failure of Bohr. Now comes the important questions part. This is the most important concept of this chapter, where this can be asked either for 5 marks or 3 marks. So 5 marks questions can be postulates with merits or postulates with demerits sometimes. And most of the times they can ask either demerits or merits for 3 marks or 5 marks, and demerits postulates can alone be asked for 5 marks. So all the postulates, merits and demerits all are given in the video very clearly. You can just read them and go for the exam to get good scores. Thank you.